paid, but NMap is free. But the choice of tool for today is not NMap is free. The main reason for choosing an NMap is it will help you identify what is that scanning I'm going to do and how exactly the process it goes
Excuse
about.
me, son. Sorry, there's a
Yeah.
background. If you can mute the microphone, please. Some people, please. It's fine now.
So basically, we're going to look at from an network scanning at much more raw level as most of it do. All right, we'll see. I'm not going to go about all the topics in Nmap. I'm going to look at certain things which make sense out there, and probably we can look at things in a different way as well. Right, all those things we'll see. But before going into network scanning, right? So what are the when we talk about networking, you'll see a lot of people talking about L3 engineer and L2 engineer, right? Okay. So in some interviews also you might get to know what do you mean from L2 and L3, right? Usually what happens in the network layer, sorry, in the OSI layer, which is used by us, any networking or any packet that is sent from source to destination, right? There are certain amount of info or data that is added to the packet, right? So this packet will help them in, I think someone else is sharing their mobile screen. Abu Bakr Muhammad. Right. So usually, so some kind of an information is needed, right? So for instance, let's say I'm sending one packet from India, and the packet has to reach US. How does this packet know how to reach to the US exactly to a device that is present out there? Right. So for this, usually when you have a postal address, when you're sending them a letter, you'll have two components, right? When you'll have something called as a from address, and you'll also have a two addresses, right? From where you're sending and to whom you're sending. And similar to that, there are a lot of other things as well. So for instance, I want to do message integrity and like it is, checking message. It is showing, being sure that the reaches of the right accuracy of the transmission. Yeah. So connection it is there, and there's live connection is there, and a lot of other things, right? Again, if you're sending three packets, it might take three different routes to the destination. How do I rearrange this packet in my location, right? I might get the third packet first, second packet second, and first packet last. So I have to rearrange this packet in particular order. How do I get this process about that? So all this information is going to be added at the OSI layer itself. Any device that is sending the packet out, it keeps on adding this data to that part, right? For instance, if this is your data, right, it is going to add different things into this component, right? So for us in this component, so usually what is there in the OSI layer has 7 layers, right? One is application layer, one is session layer, one is presentation layer, transport layer, network layer, data link layer, and physical layer, right? So the one thing which should be concerned for us is going to be these 4 layers, that the data is anywhere you're going to send the data, this information is going to be added to them. The app layer is basically about your information about HTTP and other things. Session and presentation is not relevant of them, right? Because in real time, we use something called as a TCP/IP reference model. Okay, OSI is basically used as an explanation, so it is much more easier for it to explain people out there. So L2 here is this layer 2 data link layer. Here we speak about switches, and L3 here we speak about network layer, which is about layer 3. Here we speak about router, firewall. and things like that. And this is the transport layer. This is where your TCP UDP comes into play, right? So that is where it is going to be there. So I think the time is quite limited today. So usually this in a main course, this is an entirely a separate class. We talk about Wi-Fi itself. We go in much more detail and things like that, right? So the this, whenever you see the communication is going to be based on this, right? So wherever the IP address we are getting out there, it is from this layer itself, right? And the port number, whatever we are getting, from this component of there. And the MAC address, any device will have a MAC address, right? So it is going to be dealing with this particular layer of them, right? So now my question is, MAC address is predominantly is not relevant for us. Okay, it is not relevant for us for this. For today, it is not relevant. In cybersecurity, it is relevant out there for multiple reasons, but predominantly we will not be working on the same network, right? So if it's when you're working on two different networks, MAC address is a bit less relevant because every time the packet jumps from one network to another network, it is going to change, right? So what happens in any packet is we are focused more when it comes to network scanning. We are focused more on port number and IP address. So IP address will tell which system to go, which system to connect, right? So for instance, let's say if you go to an office, there are about 1,000 systems out there, right? 1,000 devices that are there. How will I know I need to go and connect to this particular device only? The device IP address is going to be useful for me for doing that part. I will know exactly how to connect to that component of the based on that part. But the thing is that, let's say inside the device, right? Let's say we'll think about this IP address is 10.10.10.10, right? In this device, there is something called as an SSH. There's HTTPS. There's MySQL running out there, right? There could be FTP running out there. When the packet arrives here, how do I know which application the packet should belong to? Right, whenever you're connecting to a Google server, right? The Google server, when you open your browser and enter www.google.com, right, and the packet reaches the Google server, right? There's an IP address for Google server. It will reach them. Okay, that is that. But Google server will have many services, right? There will be SSH for sure. There will be HTTP. There will be MySQL in some case, or some other service is running out there. How does it know which one to connect to? Right? So that is where the port number is going to be assigned. Okay. So for instance, SSH port number is going to be assigned to 22. Then HTTP is going to be 80. HTTPS is going to be 443. This is where you'll get that padlock symbol and cybersecurity bias. It's encrypted. Here it is taking place. So I think 3086 is for MySQL. I'm not completely sure about the number, but that is there. In approximately it is there. Right. So this is why I need to know which information is running out. Okay. I will go through this one more step detail in some time. Right. So now from an attacker perspective, why I should do port scanning or network scanning, you can talk about. Why do I need to do this? Right. I'm an attacker here, right? Why I need to know which is what. So first of all, let's say there are about 1,000 devices in an office. What is my intention is also important out here. Right? As an attacker, what is my intention? My intention is data theft, access control, right? And a lot of things. DDoS or denial of service, distributed denial of service. For me, all of them should be compromised. Depends on the what is it? Let's say I want to hack a server. I want to hack a server out there. Why I need to do that? I want to data that I want to do out there, right? So there are 1,000 devices out there. So how can I know which device is important out here? How can I know which device is important out here? Right? So this is important. So I'm doing a network scan and I want to know because a lot of people, what do you think when you see movies and we see, okay, they get into a system, they hack immediately. It does not happen in real time, right? A lot of attacks that take place takes months and months of planning, right? And it is no longer a single person activity. One person cannot hack a very large scale. You need multiple things. Whatever the recent times attacks you saw, Microsoft attack or a lot of other things is because lack of negligence. It they took time to prep that particular process. They were scanning and then they very rarely you see in recent times getting an attack, and very little. It's almost impossible to get a single person. They have to be really gifted for one single person to be able to attack out them. So now this process takes on. I need to know which system I should spend time on out of 1,000 devices. Right? We are assuming this is going to happen. Out of 1,000 devices, I need to tell which devices is important for me. How do I know that part? Right? So let's say you're having a laptop out there. What ports will be open in a laptop? See, understand in ports, when I'm talking about every devices uses ports, both client and server. But the first, any port starting from 0 to 24,024 cannot be used for client server. Okay, it's always going to be used for servers. Like it is a HTTP server, it is a HTTPS server, SSH servers, and things like that. So a normal client laptop will not have ports open from 1 to 24. Okay, 1 to 24, it is not going to be there. That is not going to happen out there. Okay, if while scanning, if I see a device where it is having a port number 80 open or port number 443 open, it means that this is a server or device of importance, right? Only servers or device which are there. It may be a not a relevant, maybe a testing server. It may not have any good information on that thing, but it still reduces my process down significantly, right? Process down significantly. Instead of me running devices and trying to hack 1,000 devices, probably I can bring it down to 10 to 20 devices on that, right? I'll bring it down to 10 to 20 devices. Now I can try to focus more on this part, right? So that is how it goes, and it gives out a lot of information. Network port scanning will not leak data. Okay, it will not. There is no data, relevant data that is important that we're going to get out there. What information we can get here is version information, vulnerability information we can get here. Okay. So what do you mean from this? What I mean from this part of that, right? What do you mean by version information? Because see, it is any attack without knowing what it is running, it is not possible to attack out there. Right, we cannot blindly look at that. One of the main reasons, I'll tell you other information that is required by us is the attack for Linux is different than attack for Windows, and it is different for attack on Mac systems. They're entirely different. If I'm running a Windows machine, probably I can use an attack which is having an exe file. In Linux, that is different, right? If I identify the device as a Linux, and no port open, but I still can see think, okay, this Linux is there, it means it has to be a server, right? If Windows is there, I think it is going to be a desktop. Predominantly, that is how it is going to be there in the organization. These information will play a very important role for us, right? Multiple ways, right? So for instance, why is this important? Why is this important? Let it get updated. Give me a second. So the reason why this is important is if I get any version related information, right? If I get any version related information, for instance, let's say FTP, I can search. See here, there is an already existing exploit. How do I hack that particular component and things that is already there? And I can use this. I don't have to do much about that. Hacker can use this one. But there is a catch out here. What is this attack is going to work only on Wing FTP server 7.4.3. Right? Depending on the version number and things, this is going to change out there. So I need to know which attack I'm supposed to do that part of it. Right? So if you see, there are about 46,435 entries out there. Right? There are 46, there are different type of attack vectors, exploits that are there. So I need to, I cannot tell where, I cannot do check out everything on that. And all of them, it is not for FTP, right? Out of 1,103 entries is for FTP. If you have other things, other services running, any of them, it can be used out there. So I need to know what services I'm running out there, right? So there are a lot of other things that we see. So for instance, when we talk about port number 80, I know it is an FTP HTTP server, and if it is port number 22, I know it is an SSL server, right? So how do I go about running a scan out here? For a practical purpose out here, I'm using one Kali Linux for running, and Kali Linux comes with NMap by default installed out there. And if you're using Windows Ubuntu, you can give apt install NMap. Okay, sudo if you don't forget that. Okay, that is there. And for the victim machine or the client, I'm using something called as a B-box, right? Please don't scan public IP addresses, right? Always learn how to set up an environment as we do in our main course as well. For B-box, you set up a virtual box or a virtual VMware workstation from which you can run this labs out there. Okay, that is very much important. So this is a vulnerable machine by default. For practice purpose only it is there. This is a vulnerable machine, so I can practice a lot of attacks. And predominantly this is a web-based attack vector. Right, so that is why it's used. But we are looking into that as well. Right, for our course class today, it's going to be very useful. So you can see here, right, in the component, I'm having two virtual machines out here. One is Kali Linux. The other one is VBox, right? This is the victim machine. It's a very old Ubuntu machine and it can be used for practicing purposes, right? So before I could go, what I will need, I need its IP address. Let me check. Think I've put in a different network now, both of them in the same network, right? And you can see the IP address is 192.168.74.135, and the Kali machine is 145, right? 170, 170. So here it's very simple. Running an NMap scan is not going to be difficult. I just have to run NMap. Just give the IP address, right? 192.168.74.135. And this is what is going to happen. And you can see it went on. So in real time, this is not going to be this fast, right? Because it's in the same system, it's in a virtual network, it is easily reachable. So it is giving me the process out here, right? And you can see this is giving it a lot of information, right? So it is telling, let me increase the font. See, there's so many services that are running out here. Port number 21 is FTP, 22 is SSH, 80 is there, HTTPS is there, 443 is there, a lot of things that are there. So it means this is a very important topic, the machine out there running a lot of services out there, right? So this is very much important. Port numbers means a service is running on that. When the service is not running, the port number is not going to be open as well, right? For instance, I'll give you just small demonstration. For some other, this is a dummy Ubuntu machine. It's a brand new machine. There's nothing installed in this. Okay. So for instance, let's say if I give, let's see if I've installed anything. Yeah, it's absolutely no. Let me check. What is the IP address for this? 153, right? So if I scan here, same thing is going to be there, right? Same thing. I've just change the IP address from 135 to 153. Was it? What was it? Yes, 153. So now if you see, there is no, we'll get nothing out here, right? Because it's an absolutely brand new system. There's no service running out there and no information is going to be there out there. See, it is telling the host is up, but it is not getting any information. No ports are open out there, right? So that is the process of the. For instance, now, because if no service is running, service is basically some kind of a program that is been attached on it, right? So HTTP server, web server, and things like that are all going to be service part of it. So now what I'm going to do is that I'm going to install Apache server. That is your web server here. Okay. Sudo apt install Apache 2. And when you do this, when this server is running, a port number is going to be assigned to that by the server itself. So the Ubuntu server is going to give a port number to Apache out there. Okay, so let's get it installed. We'll install it. Just give it a second. Okay, so let's see. Is Apache server running first? It is running. So if I go back here, give localhost, and I see there's a dummy default page running. I've not put any kind of a code or any rendering or HTML page, so it will not show. It will show me a default page. This is just for practice purpose. So now if I go back out here, server is running out there. Will I get this port number 80 open out there? Let's check out there. You can see now as soon as that service is running, the port number is open, showing as open, right? If I stop the HTTP server, that port will be again be closed up there. Okay. We can also see do the same thing for installing SSH server as well. And we can see now the port number 22 will be open after doing this. So what I mean to say is that only when you are doing the application install, that particular port number is going to be open out there. Otherwise, it is not going to be available out there, right? So SSH is not running. Is running now. So if I go back and run, you can see both the port numbers are running out there. So that is how it will work. So now only the server components and things are able to do this process. So now you should have the question is, how does NMap know if a port number is open or closed? How does NMap know about that part? What message has been sent out there? What do you think? Someone is asking a question. Okay. Right. So how does NMap know this is the scenario out here? Right? How does it know which port is open, which port is closed out there? So one of the questions you might get in an interview whenever you go is that, can you explain me TCP three-way handshake? Okay, this is what they're going to ask about. What do you, anyone, how many of you know what is a TCP three-way handshake? Any idea about it? Yeah, Kamar, please let me know. So usually there are two protocols at the transport layer, that is layer 4, right? These are the main thing, the protocol that is very much where your internet is, whatever we are seeing is because of this particular layer. There's something called as a TCP protocol and something called as an UDP protocol, right? So UDP is like a postcard. Whenever you go on a vacation and you'll get postcard, you can place it back to your house, just as a memory that you have been there, right? But the problem with postcard is it might reach, it might not reach. There's no guarantee that it will reach out there, right? Whereas in TCP is like a, just like in your Amazon delivery, right? Whenever it's got delivered, you will get a status update, right? Telling that that product was delivered to you. So UDP, let's not worry about UDP as of now. I'll come to that if there is enough time today, right? So let's talk about UDP. How does UDP know whether the packet is reached or not, right? How does it make sure the package reaches the destination? For this, what happens is that there is a initial handshake that goes on with that. Okay, so usually in TCP, when you're using TCP, all your any of your email, website, and everything are all going to be based on TCP protocol itself, right? Before I could send, let's say I want to send hi, right, from A to B. Before I could send this, there's an initial handshake that goes on, right? So what happens whenever you call someone, right? You're not going to start speaking to that person directly. First, you're going to say hello, then the other person will say hello, then you'll identify who it is, and then you'll have a greetings, and then you come to the point where did you call him out there. So that is called as an initial handshake. The same thing is going to happen out here. So what happens is that when you're using TCP, there are three messages that are exchanged between the devices before I could send the actual message out here, right? What are those three messages out there? The first message is called sync. So sync is basically telling I want to connect. Okay, that is the, and then since TCP is connection oriented, what it is going to do is that For every message I received, I'll send back an acknowledgement telling that I received your message. I received your message. If I don't get the acknowledgement, I will resend the same packet out there. That is what is going to happen out there. So since I'm using TCP and A sent a message, B what is going to do is going to send back an acknowledgement to A telling that I received your initial request to connect out there. At the same time, it will also tell C, I also want to connect with you, right? It is telling I also want to connect with you. So it is sending a sync packet and it is sending an acknowledgement back, correct? So now the third component is going to be the ACK. For this sync, I need to send an acknowledgement back that is going to be sent in the thing. Once this three-way handshake is completed, only then rest of the communication take place, right? Whether you're working on a website or anything, this is going to happen first, only after the rest of the things is going to go out there, right? That is what is going to do. So now let me show you a practical example using Wireshark. I know this, probably we're talking about NMap, we're working, but once you understand this concept, any NMap scan is going to be much more easier to understand what's happening about that. Okay, so I'm going to keep on any. So don't worry about the process, what I'm doing here. Just see the data once it's done. Okay. I'm connecting to a website called testfire.net. Okay. So before that, let me clear the screen. So I'm doing all this because I want to capture that first three handshake. Okay, so I'll stop here. I'll stop here, and you could see where it is. Yes, I think we missed it. Mm, let me check for the. Yeah. See here, you could see here. I will not be able to zoom in much. Before I could open this web page, right? Before I could open this web page, where is this web page working? If you remember, we just created this web page in this other machine, right? Website out there. So I'm able to open that particular thing before even I could get the data. What sense an HTML content is going to be sent out there before I could send the data? That there was a three-way handshake that is happening out there. So it is telling send a sync packet, SYNAC and ACK is there, and only then an HTTP request is sent telling that I want to connect to this particular process out there, right? Once that is done, what is happening out there? It is sending back that information. What? This is the content that is sent back out there, right? It is sent back the HTML process. See here, this is the HTML content that has been sent for me to open this particular page out there. That is what happens. Before any of that, it could going to happen out there. It is going to check for this process. Three-way handshake is going to be there. So this is how it is going to do. Okay, this is how this scan is going to happen out there in an NMap. So what it is going to do is and NMap. This is a very tricky way of doing it. It is very clever at doing it, and all your scanners are doing this itself. So now this is a device. This is a device, and let's say HTTP is running. Yeah, so port number 80 is open out there. So NMap is running on my Kali Linux. So NMap will send a sync packet to where port number 80 out there. If the port number 80 is out there, what is going to happen? I'm going to get back a SYNAC request. I'm going to get back a SYNAC request out there. And now I know port number 80 is open out there. Let's say I will send a sync packet to another packet out there. Port number 81. If this is there, what is going to happen? It is going to send a reset signal out there. So if I get back a reset, it knows that 81 is closed. So it does it for all the ports. When I just run NMap and IP, if I give which I ran now, it is going to scan top 1000 ports. Right? It is going to scan top 1000 ports out here. So meaning every time I run this part, there are 1000 packets that is going through, and it is waiting for the response. And based on the response, it is going to tell which ports are open and which ports are closed up there. Right? When we did for this, when we ran the scan for the B box, right? If you remember here, we ran for the B box. So it is running top 1000 ports, and out of this, these are the ports that are open out there, and it showed out there, right? And whereas here it is showing only 2 ports, it sent 1000 packets out here, right? It is telling out of 1000, only 2 ports were open out there. So how many ports are there according to you in any device? In any device can have up to 65,535 ports. It will start from 0. Okay, including 0, if you count, there will be a total of 65,536. This is like 2 to the power of m going to be there. Okay, so that is how this is going to go for you. So now each and every time I'm going to look into that component out there, and that's how I'll get to know which port is open or closed. Right? If let's say if the particular port number is not open, what is going to happen? Right? Let's scan the network again and see. Let me stop here. See here, this is there. And what I got back. So I got here, it is telling I got reset and ACK, right? Meaning ACK, meaning it is giving an acknowledgement for my sync packet. Before this, I sent a sync packet, right? And it's giving acknowledgement I got a sync packet, but unfortunately I cannot communicate here because the port is closed and the reset. That's why I'm sending a reset as a response for that. So if that particular port number is open, it is going to send back a SYNAC packet. If it's not closed, it's going to look at that part, right? So let's do one more example out here. What we'll do now is we will scan both port number 80 and 81. Okay. Both I'm going to do it here. So let's see what is going to be the response for that. See, let me stop it here, right? So it is going to got a reset link for port number 81 here, and for port number, where is 80? Okay, sorry. See here, for port number 80, what is happening? I'm getting a CNAC back. For 81, I'm getting a reset packet, right? So that is what happening. And here there's something called as a reset is happening. TCP handshake is not completing. Okay, we will keep that in mind. We'll come back to that later. So if the port is opening, I'm getting SYN. For SYN, I'm getting CNAC. So if the port is closed, I'm getting back response as reset and easy cap. So that is how it is able to do that part. By default, NMap is going to scan only top 1000 ports, right? It is whenever you're scanning in actual infrastructure, right? Let's say there's a server. Usually what is going to happen is that it is not that you're not running blindly like an hacker. You are a dedicated penetration tester, you are a security auditor. The company which has hired you is going to give you a list of IP addresses, right? This list can be sometimes only one IP address, and sometimes it can be all the way up to 1000 IPs also, right? In some cases, it is there. In some cases, every day they'll get 20, 200, 300 IP addresses because let's say if you're a huge banking company which has multinational and more than 30, 40 countries you have branches, amount of servers and systems will be very high out there. Okay, so it will be there. But you most of the time we are going to get it. IPs are going to be there. Let's assume for the sake of argument, I'm going to get one IP 192.168.74.135. Okay, this is our B box mission IP address of them. There are about 65,535 ports open on them. So are you going to scan only top 1000 ports or what you're going to do? How many ports you're going to scan? Are you going to scan 1000? Are you going to scan 5000? Are you going to scan 10,000? How many are you going to scan out? Whenever you're scanning any device in your network, you've been supposed to scan. You're supposed to scan all the ports out there.
One.
Yes. Yeah, please go ahead. Right. The main reason is why is that I have to scan all 65,000 ports out there. Because it is not mandatory for HTTP server to run on port number 80. I can change the port number to anything of my choice. It is not mandatory for running HTTPS on port number 443. I can run on anything else also. Right? If once few Python applications, web application will run on port number 8000, your Tomcat Java application will run on port number 8080 by default. But you can move it to anything else out there. That is not going to be an issue of features. In that case, you have to be very careful out there. Right? There may be additional servers running on different ports out there. So how are you going to select that option out there? So usually if I want to scan a single port, right, I have to give -p and the port number you want to scan, right? You want to be, this is how it is going to be there. If I want to scan all 65,000 ports, -p is going to be used by you. Or you can give -p 0 to 65,535. Let's say if I want to scan first 400 ports, I'll give 0 to 400 out here. That is how it is going to go. Right. So that is how the process is. So you can give port numbers and you can also give -p ports, different ports you can give it out there. Right, very specific. But predominantly whenever I'm running scan, for training and map and things, I'll talk about this, but majority of the time I'm running scans for all the ports out there. I run scan for all the ports out there. I'm not going to specifically tell don't run ports any specific node. That's not, you should not as well, right? For instance, let's say if you remember in the Ubuntu server, we ran the SSH on port number 22, right? Let's say what if I change? Port numbers for SSH. sudo vim/tcssh, right? Just give me a second. Let me install the editor. It's a brand new system. That's the reason there's nothing installed. So here I have to come down. I have to give the port number here. Let's say I give the port number 4444. Instead of running port number 22, I'm saving the port number is 4444. So now, if I try to scan this network, that particular device with the NMap, right? Instead of giving the port number, I'm going to give randomly. So the first, by default, it is going to scan the top 1000 ports. The port number 44 is there in the ports as well, but it is not able to identify which service it is running on, right? If I give, let's say, let me run the same thing again. $44,444. Will it show up now? See, now SSH service is running out there, which is running on what port? It is running on 44,444 port number. It is running out there, but still it is not showing up out there. So now the reason is it is only scanning only the top 1000 ports. In top 1000 ports, this port number is not present out there. So if I want to check that every port number is covered and everything is confirmed, checked out there, what I have to do? -p and press enter. And now it is going to scan each and every port. So meaning it is sending a 65,000 packets to the destination in a very short span of time and is getting back a response of that. Okay, that is how it is going to check for all those things out there. So see, service name, it is showing as still Cognex data man out there. There's some other port number is assigned. Technically it has been registered for something else, but it is not mandatory. It should be running out there in this port number. Okay, that is what is happening out there. So now this is how you check for ports. Okay, which port is open and now we understand why it is important for us to do all that. So because we have seen in real time, what happens is that why I should scan one more reason, scan for all ports. This happened in real time. Your malware, right, may be sitting in a hidden in a port out there. Right, and it may be hidden in a particular port out there. So at that time, how do I know? Right? So we helped one organization when we ran the scan, we ran all the ports, and one suspicious port was open out there. And we checked with them, they told no, that port number is not, we're not aware of that port. And when we checked, there was some malware installed on that particular device out there. Okay, so that is also one of the reasons why we need to scan all the ports that are available out there. It's very, very crucial for us. Okay, so that is how this goes out there. So you need to scan and you need to scan all the ports out there. By default, this is going to go, and this is not going to be this fast when you're working in a real-time organization. Because all 65,000 now 65 packets have to 1000 packets have to travel within my system in my test environment. It is going up fast, but in real time Certain times we'll have around 10 to 15 servers. Probably it will take a half a day or sometimes almost a day based on the network speed of that for scanning what we did just now. So that is very important for us to go, right? So any questions, guys, till now in terms of networking and map scanning out there? Before I could move further, I want to check anyone is having any questions. Yes, come on. Anyone is having any questions?
So what, which tool is more means useful in terms of NMap and Wireshark?
I'm using Wireshark here just for showing how it is happening out there to show actually what packets are sent and received, how it is behaving. In real time, we are not going to use Wireshark to that extent, right? Wireshark is predominantly used by network engineers for monitoring their network, troubleshooting network issues. Whereas as a pen tester, you're not doing any of it. You're just trying to scan out there. So it's not going to be often. If you're checking why you're having scans are not working properly, probably in those situations, you will probably would like to check in Wireshark. Otherwise, you will not use. And predominantly, you may not use NMap also. All right. The reason for doing NMap, as I told here, is to understand how your Nessus or quality tools are working in the background. The main reason is when these scanners gives an output, you have to discuss this output with the client, telling that this is what it showed out there. So how did that come to the conclusion, right? So because if there's a vulnerability, they have to know how to fix it. So at that time, you need to be aware how the scanner is working and how it is behaving and things like that. So this will help you with that process.
So in industry point of view, means for us, learning Wireshark is not so important because we want to just dive in the cybersecurity world. So for that point of view, we must focus on the NMap.
Yes, priority wise, I'm not telling you should not learn Wireshark, but priority should be NMap first and probably Wireshark at a later stage, right? So then again, NMap is basically we done is a reconnaissance phase or information gathering phase. Whenever you start any engagement, when we talk about app pen testing and application, first thing you run is you run a scanner out there. So that is how it's going to do. So you run NMap. And certain times the client will not be keen on you running scanners. At that time, you'll have to run NMap model. Right? So any other question, guys? Hope I was clear, Asim. Any further questions? See, you guys have to think, right? What it has been taught on the YouTube or any certification pen testing courses and things, it's different than what happens in the real-time process of that, right? There's a lot more reporting functionalities you need to be aware. The approach is going to be in a very standardized approach. There is no reconnaissance phase in pen testing when you're doing for a client, because why? The client is going to give you a lot of information. Right, a lot of times when you're doing web application and pen testing and things, he'll tell you this is the IP address of the server, this is the software it is running on, this is the operating system it is running on. Probably he'll give you a demo on how the application is working on. So you're getting a lot of information, but after that you're doing the pen testing of that. All right, so there's the way the approach is going to be a bit different. You're not going to spend a lot of time on reconnaissance of that, right? Very little time you're going to do. At the same time, you will not have unlimited time like an hacker would do, right? For an hacker can sit on this one particular application for 6 months, 1 year, or even 2 years and crack it. Whereas you will not have that timeline with you. Probably you will have 3 days approximately, in some cases 1 day, and not more than 5 to 6 days in a single application, right? If the application is very huge, Then they are going to divide it into features, and each feature you'll be working for. Like, let's say if you're having a core banking application, when you're working for a big multinational brand, banks out there, the applications will be very huge. You can't cover it in 5 days. What they'll do is that they'll divide it into different features, and then they will move from there. Right, and each feature you'll have 1 or 2 days to work on. Then you create pen test, give a report, and goes on from there. That's how it goes. So that is that. So now next question here that will come here is type of scan that is going to happen. So there is going to be quite a bit number of scans out there. One is the TCP scan, one is sync scan, right, or stealth scan, and one is called as a UDP scan out there, right? So the difference, this UDP scan is that if you, I'll come to this after I finish this. Okay, in TCP scan and stealth scan, what's happened? What happens? Let's say there's a server and a client communicates, right? If the three-way handshake is completed, that is your SYN, SYN-ACK, and ACK that is completed out here, server will store a log telling that, let's say this client IP address is 10.10.10, that 10.10.10.10 connected. Okay, this information is going to be stored on the server. But as an attacker, what is your point? If you remember when we did in the security awareness and pen testing, we need to clear track, right? We need to give less information about that we were in the system at all, right? That is what is important. So in TCP scan, if you give -ST option, it is going to complete the three-way handshake that is going to be there. Okay. So, but if you're using a stealth scan or a sync scan out here, SS out here, it is going to send a sync, right? I'm going to get back SYN-ACK out there. Okay. As soon as I get SYN-ACK, I know the port is open out there. So it is not mandatory for me that I need to complete the connection. I don't have to send an ACK out there. What it will do is that it will destroy the connection, then and there it will send a reset. So now the log is not going to be stored out there at all in the server, telling that the connection was connected or not. So this is what happens out there. By default, NMap scans the sync scan. If you remember in the Wireshark, when we did, right, when we did for port number 80, this is what is happening over here. From the 145, reset it was sent for 81. But again, I sent from Kali Linux 145 to 53, third point. I send a reset link to that part, telling that I don't want to communicate further. I'm determining the connection out there. So when this is done, so this is how it is going to happen out there. So these are two important things out there. Okay. So by default, it is going to run out there to keep it there. But nowadays, this is not, good way to hide. Actually, why? Because nowadays we are having all getting a firewall, next generation firewalls we are getting. So it will look for this behavior. Scans, then it will raise an alert telling that someone will try to test your network. Are you sure you want to do that part? Nowadays it is scanning networks, pen testing is much more, very, very difficult out there because firewalls take case and you'll get something called as an this one what is that, IDPS, yeah, intrusion detection and prevention system, and firewall come built in with IDPS nowadays, so they can look for patterns and they'll block you. So we have to tell the client to whitelist our IP, whichever I'm sending out there. Make sure, ask them, see, I'm connecting from this IP, please whitelist it so that I can run the scan. Because after recently we scanned one network, within 3 minutes we got logged out. right? Because the firewall thought we're trying to hack. It did not even allow for us to hack it directly. Got a lot of packets in a short span of time, it stopped. Right, then we had to write them a mail telling that we could not run the scan, and they whitelisted our IP, then we were able to continue. And that's how it goes, that's how the process works in that process, right? Okay, so that is how it goes. So now my question here is for the UDP scan, right? In TCP always is going to be three-way handshake, right? So if I send a SYN, I'll get back SYN-ACK or I'll get a reset ACK, right? So based on this information, I can tell whether the port is open or closed, right? UDP does not work that way. There is no handshake out there. UDP where it will happen, why that's why it's called connectionless approach. There is no acknowledgement or anything. There is no data security out there, right? There is accuracy, data reliability is not there. Whatever it gets, it keeps on sending in whichever order it wants, and it does not care about. I don't get any kind of response acknowledgement that it's something reached or not, and I don't care about whether it reached or not. Right? Predominantly, this is used for DNS and voice, right? Because in voice, especially, your speed is important. So I can, let's say I'm having hello, how are you? I can have short 1 millisecond of data missing out there. It will not affect my performance, right? I can still understand, the other party can still understand of them. But if I have the delay in the middle, right? Hello, how are you? It has been divided into 10 and that 10 reaches half a second late. I cannot make understand what's happening out there. So their speed is more important than reliability. In those situations, UDPs are used. So since acknowledgement is not coming, right? How do you know if UDP port is open or closed? Okay, so one lucky thing is that most apps run TCP. Okay, we don't see any reliable or any important application running UDP. Okay, that's one good thing. So, but how do I know if the UDP port is open or not, since there is no acknowledgement available out there? Right? How do I know about that? So here, lack of response is considered open. So what I mean from that part. So as I told, right, UDP is a connectionless part. So let's say port number 95 UDP is open. If I send a packet to that, there will be no response. Okay, because the port is open. But let's say I send the same packet to port number 96 UDP and that port 96 is not there or closed. If the port is closed, I will get back an error message or a reset flag telling that port is not there. So if there is no response, means the port is open. If there is a response, it means the port is closed out there, right? But this is a very inaccurate way of knowing. UDP's scan is highly inaccurate. You cannot do anything about it. Main reason is, let's say there is a firewall here, right? And if I do a stop 1000 port scan for UDP, it will drop all, right? Drop for UDP package, because why? I would have configured here, particular ports only should be open on there. So now in this scan will tell all 1000 ports are open because there is no response for that. So it is highly inaccurate. UDP, we don't run much. We do run it and check what's happening. Is there something running out there? But usually it does not work, right? It is very highly inaccurate out there. Firewalls, not only at the network level firewalls, even system firewalls will block these ports. So we'll not know for sure. Okay. So running these scans are very simple, right? And what we have to do is for running sync scan, I have to give ST to run the scan out there, and for sync TCP scan SS, sorry, ST and sync scan SS, right? And for if you want to do it for UDP, run it, right? So UDP is, as I told, it is very highly inaccurate out there. And if you remember, I told we got logged out in one company because we were sending too many packets out there, right? So how do I limit the number of packets sent? Or how can I, is it possible for me in NMap to vary the speed of sending out? That is totally possible. For instance, I can give -T1. This is the slowest, and it will go all the way T2, T3, T4, and T5. Yeah, this is the fastest going to go out there, right? For instance, if you remember, I can run the same scan and I can give T1 out here. Okay, and you'll see it's going to run a long time. It's still running actually. Okay, if you do the same thing, if you do the same thing with T5, it will run almost instantaneously. See, it's over as soon as possible. It is not giving space between, probably it is sending multiple concurrent port requests to the client out there and to the victim out there and getting a response back. Whereas in T1, it is sending a short burst. There's a lot of space between the packets. This is basically to keep your scans slow and secure, so that the firewall will not pick that someone is trying to send a large number of packets into the network. It will hide all those information out there, right? This is very, very crucial. This happens in real time. That is one of the reasons why it will take months for preparation time, because maximum time goes on for any attack is the preparation. And you have to be very slow and methodical when you're scanning a large network out there, right? When you're doing actual hackers, what they will do in a red teaming activity. Very slow and it goes on very slow out there. Right? Whereas when we go a security audit, we tell them we are coming there. We have a short span of time to work on, so we are going to run in full speed and give us a whitelisting of our applications out there. So for that reason, they will tell, okay, this is the time when the network is going to be very slow. Very little people are using run scans on this time. So usually middle of the night for the organizations will do run it. Main reason is that they will know that it is us, we are pen testing, and they will be able to identify that testing is going on out there. Because in the morning, if you're doing it in a peak hour, it could actually cause the server to crash sometimes, which has happened for us many number of times, right? So customer will tell they want to scan the production server and things. We tell ideally we would not recommend. They'll tell no, nothing is going to happen. We have a very good server capable. We run the scan, it crashes immediately, and they're on the call, right? Telling that why do you know how much, what was the scan pattern, right? So because we also test that as well, because we need to test for DDoS as well, right? Denial of service attacks and things like that. So see, the T1 is still running. If you can see, it is still running out there. It will take a very long time to run, unfortunately, right? So, but it will get the job done. So any questions, guys? Any questions till now? Fine. So there's next one we are going to look at is something called as an -SV. This is something called verbose. It will give you more information about it. For instance, if you saw previously, we did all the port numbers, right? We did all the port numbers. Let's do it with T5 out here. And we saw port number 4444, and it showed that it was not running SSH, it was telling it was running something else, cognisdataman.com, but that is not there, it is running SSH. So I need to get more information. I need to know if HTTP is running, what version of Apache server it is running, and things like that. I need to know additional information. What will I do that? For that, I'm going to add the information -sv of that. If any port is open, NMap will try to send some additional information there, additional packets or additional data, check more, get more information about the service running it is there. So I'm hoping I can get the Apache version, and I will know that port number 44,444 is running SSH. Let's see. And this is going to take more packets, guys. Okay, it is probing more information. So it is going to be more than 65,000 port packets here. So even though it is running at T5, it is taking a bit more time now. Right, you see now. Now it gave me a very good accurate update. Tell you I'm running an Apache version 2.4.58. It was having some vulnerabilities, so it has been patched by Ubuntu. Then again, open it. Previously it told Cognis Dataman was running on 4000. Now it is telling accurately. It is telling I'm running an OpenSSH 9.61 P1 Ubuntu. This is the exact version it is running on. Right, and it is even able to tell the MAC address of the device, and it is telling the device belongs to VMware. Right, so some way I can know this is running a virtual box. So this is what you get in a version. So now I got this information now here, right? I got this information. I'll go to CVE details, probably paste my product information out there, Apache HTTPD. Let's say, let me go to products. Let me search the product name HTTPD, HTTP, Apache. See the second one, Apache HTTP server. Vendor name is that, and I can get a lot of version 2.4. We are running in a different, sorry, I think. Searching here is a bit of an issue. Product search. Wait a minute, probably I'll go versus this. CV details. Jeez. Here is having 301 vulnerabilities, and the latest one is CV 2025 54090. Right, this is the number, and need recommended. So any a bug in Apache server. So anything below 2.4.64, it is having a bug out there. This is the latest version that is safe, 2.4.65. Okay, so what is the version we have got? 58. Technically, this is the vulnerability server with a vulnerability other. In this case, it is not. You can see there's a bracket Ubuntu. It means that Ubuntu has fixed this bug for themselves, right? Because operating systems will not, update servers that easily. They will write their own patch for that particular version. They will not patch to the latest. They will not install latest one. They like to be having a stable versions of that. But if this Ubuntu is not there in the bracket, and if this is only this much is there, it means it is having a vulnerability, right? For instance, when you do the bbox mission, I will remove the scan all ports because I don't want it to take a lot of time. I think 35, right? Here it is using a vulnerable Apache server. It is using a vulnerable open, or SSH as well, right? That is. Since there are more services that are there open out there, so it is giving more information for that part. Okay, so let me do one thing. Let me stop this. Let me give a particular port number. A bit more faster. Is it 35 only, right? Or are we scanning the wrong 135? Yeah, see, if you go look at this, this is a version that is having a vulnerability for sure. Even though it is being patched by Ubuntu, it's still going to be vulnerable out there. There's also one more version out here, which is option out here, which is much more potent than -SV, is -A, right? This runs a much more detailed scan out here. For us, it will take a bit more time, but it can even identify what operating system it is running, whether it's Linux, Windows, and things, and sometimes even list out vulnerabilities as well. Because if you remember, NMap is not only right for scanning and checking which ports are open. Recently, I mean, for some time it is there. It can even check whether there's any vulnerabilities there or not, right, in any of your machines. But it is not as accurate as Nessus or Quali or any other commercial tools, right? So, but this is a very good tool for us to understand what's happening out there in real time. So any more questions, guys? I think we'll stop here. We come to the end. We'll stop. Let's see for 2 minutes what the output is going to be there for -A. But any more questions related to network scanning and what is our approach when you're doing in real time? How do we go about that? Any questions related to that?
T5 is the fastest. He will NMap will scan fastest. No? T5 is the fastest.
Correct.
Yeah. So it depends upon the situation, which time interval we want to scan as much fast as we can.
Right. True. Because certain time, what happens is that it is certain networks or devices can be sensitive, right? They will be running on limited resources. So if you run it with full scan, they will fail, they'll compromise, they'll crash. Because understand,
by default, it is.
I think by default it is running in T4. It is not running in full speed. I think it is running in T3 or T4. I'm not sure about that. Right. By default, whenever we are running NMap scan, first it will do a ping. That is your ICMP, right? Step 1. Then it will do a DNS lookup. Okay, then it will do a reverse DNS lookup of them, right? If you give an IP, it will check is there any domain name assigned to that IP address or not, right? So only then it is going to start scanning the process for you. That is your top 1000 ports. Any other questions?
Sir, I have a question. I'm writing in chat section.
Yeah, please go ahead. Yeah, can I enter the question in the chat?
No, sir. But for us, like we are going into the cybersecurity, so we had to means do a lot of practice type.
See, the practice type depends on what is your budgeting is, right? So cybersecurity, unfortunately, it's not cheap, right? If you want to really practice on infrastructure and things, you can go with hack the box environments where you can get a lot of missions to practice that you can try, or you can try for free vulnerable if you know how to set up machines and things, right? For Portsfigure labs are also there for doing web application, right? But if you are not good with Linux, I think you should spend more time learning Linux services and everything, because everything spreads from there. So Linux is the root, the main where it will go, wherever you're shifting, whether you're going to DevSecOps, you're going to web application, you're going to infrastructure scanning, or even if you're going to SOC, right? In some cases, Linux is very much important.
Okay. But then Linux is also very vast, so basic information of Linux will be sufficient, or we had to
No,
go advanced.
basic will not be enough. Look from uh, RFCSA as the bare minimum for it. You know, whatever there in the concepts in RFCSA certification. You don't have to take the certification, but you should know how to set up FTP, HTTP, virtual hosting, MySQL. How do you generate a certificate, SSH, different services you need to know how to do that and configure cron jobs and things like that. Basic running, installing Linux, moving around will not be enough for you.
Hmm.
Because if you don't know how a web server runs,
Hmm.
how do you hack that server?
Yeah.
Right? You can't pen test without knowing how it's working. Right? And predominantly, if you are going into web application testing, you want to be really good in it, you need to know programming as well, because you need to know how the application is behaving and interacting. That you need to understand.
Okay. One last question. Actually,
Yes.
I'm much focusing on that blue teaming like SOC defensive role. So for that purpose, Linux will be how much Linux I have to do.
SOC not that much, because SOC may be required more as well. Because understand what happens in SOC is that we're supposed to get logs from servers. Okay,
Hmm.
so SOC has a very limited career structure when it comes to cybersecurity, right?
Uh-huh.
So if you're really keen on that, you can decide.
Uh-huh.
SOC, you're getting logs from everywhere, right? Your endpoint,
Uh-huh.
that's your laptop servers and everything, especially Linux servers. It will
Uh-huh.
tell which command was run by which administrator at what time. It will generate an alert for that. But you need to know how to get that alert, which file will get that alert, and get that alert to configure the server to send that alert to the SOC center, right? So you need to
Uh-huh.
have that much more understanding out there. And again, you might need to know how to write rules and regulations in the SOC environment as well. So it
Uh-huh.
depends, right? If you're using Splunk, it is different. If you're using any other tool, it's going to be different, right? Changes drastically.
Okay, thank you.
Sir, I think we are done for today. We'll stop here.
Oh, Karthik, it was really fantastic. Thank you for all your effort.